Example number 7 would ask us to find what intervals the function f defined by x to the third minus 2x plus 6 is increasing and what ones it is decreasing. Okay, so that's what we've got to look for. Well, the easiest way to find where it's increasing and decreasing is to take a look at its derivative. So f prime of x is equal to 3x squared minus 2. Now the question is, when is this guy positive and when is it negative? So to look for that, what we'll do is we'll take this guy and we'll figure out when is it above the axis, when is it below the axis. So when is f of x greater than 0? When is f prime, of x less than 0? And I guess we'll also figure out when is it equal to 0. Okay, so let's go ahead and figure that out. Well, we've got 3x squared minus 2. Let's set that thing equal to 0 because that's f prime. So that gives me 3x squared is equal to 2, or x squared is 2/3, which tells me that x is equal to plus or minus the square root of 2/3, or plus or minus the square root of 2 over the square root of 3, which is plus or minus the square root of 6 over 3. That. Okay. Now, what we should do is we should figure out at these points right here, okay, at those 2 points, this function, by the way, looks something like this. So here's negative square root of 6 over 3. Here's positive square root of 6 over 3. These are the intercepts of the derivative, and we know that the derivative goes like this, comes like this. So that means that the function is increasing whenever the derivative is positive, meaning up in these spots. So f of x is increasing when f prime of x is greater than 0. So when does that happen? Well, that's from negative infinity to negative square root of 6 over 3 union square root of 6 over 3 to infinity. Then f of x is decreasing when f prime of x is negative. And f prime of x is negative on the interval negative square root of 6 over 3 to square root of 6 over 3. And so that's really all we need to go ahead and work this computation.